Hey everyone. Hey everyone, I am back with some reviews of logarithms. So I found this worksheet online that someone had posted. It's an Algebra 2 worksheet, and I wanted to use it as a review. So again, all this content has been taught, and this is reviewing. So if you feel like, wait a minute, I don't know the base, you might need to go back to pre-recorded lessons or other resources to get them. This is take 2 on this recording. My first one, I bumped my cord and it disconnected and did not save my recording. So try again. So here we go. We're going to start off real basic, and we're going to go from exponential from logarithmic form to exponential form. So it's really important that we know how to change from one form to the other form. Because we're going to use that later. So we have a log base 2 of 64 equals 6, and so we want to remember that whatever our base is our log. So if I go just to general form, just to give you a reminder, log base b of a equals x. That is logarithmic form, and the exponential form is b to the x equals a. And so log base b of a is equal to x, and so my base, because my base, log solve for power, so b to the x. So we have this nice flow. B to the x is a, or the log base b of a is x, and we can interchange our forms there. Okay, so moving on this first one, we have a base of 2 to the power of 6 is 64, and that is a true statement. 2 to the 6 is 64. Okay, another one we have here, 4 to the power of negative 3 is 1 over 64. And I just want to give you that reminder from we have to do some of this with mental math, that when I have a negative exponent, that pushes my number to the denominator, or takes the reciprocal. And so I would have 1 over 4 to the positive 3, which is 1 over 64. All right. Here they wrote in the base 10, but remember, log base 10 is your common log. So you might see the problem written simply as log 0.01 equals negative 2. So you might not always see that base, but we know it's base 10. So 10, I like to fill it in there, but 10 to the power of negative 2 is 0.01. And again, that follows that rule, that this would be 1 over 10 to the second, which is 1 over 100, and there is our 0.01. Okay, now we have exponential form, and we are going to change it to logarithmic form. So I have a log with a base of 2. The base is my base of 32, and that gives me 5. So log base 2 of 32 is 5. Okay, I have negative power here. So I know that's going to move it, but I also have a power of 1/2. So this is a log base 5 of the square root of 5 over 5, and put that in parentheses, is equal to negative 1/2. So if you know your power properties, you would be understanding that if I have this 5 to the power of negative 1/2, that would be 1 over 5, still to the power of 1/2, and you'd have to know that the power of 1/2 is the same as a square root. So we'd have the square root of 1 over the square root of 5. Square root of 1 is just 1, so that's fine. But if we go back, we can't leave 5 in the denominator, so I'd have to rationalize the denominator, and that is where I get my square root of 5. And down here, I get the square root of 25, which is simply 5. So I know that all we had to do was write exponential form to logarithmic. That's it. We were done. But I wanted to show you why that power of negative 1/2 turns into this number. Okay, so back over here, same thing. A negative power is going to make it 1 over 10, which is 0.1. But if we're changing it, it would be a log base 10, or just log, of 0.1 or 0.01 is equal to negative 1. So you might also see the answer as log 0.1 equals negative 1, given that that is a base 10. Okay, and the next set, we are going to use some mental math to solve for x. Now, none of these say equals x, but I like to give, just like this teacher did, and set it equal to x. So when I look at this log base 2 of 8, I really know that this is going to equal a number, and so I'm going to just set it equal to x, or any variable you want. And there's my pieces. 2 to the power of x is 8, and then I might need to mess with my calculator some, but I can find out that x is 3, and that is my power. So log base 2 of 8 is 3. Same idea, set this equal to something so we see the pieces, and I have 8 to some power equals 64, and we know that 8 squared is 64, so my x value is 8. We have this, and so we have a base of 6 to the power of x is 216. So I know 6 squared was 36, and it is a power of 3. So you might want to double check that in your calculator, but it does grow very quickly. All right, now this one I know without doing any math, and I know the answer is 1. And that comes from this logarithmic property. And so one of the things I forgot to mention at this beginning of this video is I think it's really important that you know all your logarithmic properties. This is where I'd be writing note cards or having a note sheet as a reference and making sure I know my properties. Log base b of itself is always 1 for the rule that b to the first is b. So log base 7 of itself is going to give me 1. Even if I forgot that rule, I could just come in there and say, hey, 7 to some power equals 7. Well, I know that power must be 1. So I can still figure it out, but boy, is it quick when I know the rule. So when I come to this number 11, and I have log base 6 of 1, I already know the answer is 0 because it's another logarithmic property. And this property is log base b of 1 will always be 0 because b to the 0 is 1. B can be anything but 0. 0 to the 0 is undefined, but any other number to the power of 0 is 1. Again, I can just come in and work it out. 6 to some power equals 1. Okay, well 6 to the first is 6. And 6 to the negative 1 makes it 1 6. So we have to sort of have those ideas, and we have to know our rules. Anything to the power of 0 is 1. Okay, I have log base 8 of 1/8, so that's going to be 8 to some power equals 1/8. All right, now that I know that, I see the 8, but I see it moved. And so that's going to be a power of negative 1. Same idea here. I have a 7. I know to get 7 to 49, it must be a power of 2, but it moves, so it's going to be negative 2. So this would be 7 to some power is equal to 1 over 49. And so that would be a power of 2 to get the 49, and it's a negative power to move it. So it would be x is negative 2. We have log base 9 of 1 over 27. Now this one's a little bit different. I'll set it equal to x, but 9 to some power will not give me 27. Now first thing I know is it's got to be a negative power because it's been a now number between 0 and 1. But 9 squared is 81. So we have to think about this a little bit. 9 to the first is 9, 9 squared is 81, so I'm guessing it's between 1 and 2. And the power happens to be 1.5, so you could mess with it. Another way to look at it that might be a little bit more advanced than where we're at this point would be, let's change this to 3 to the second to the power of x equals 1 over 27. So I'm changing it to 3 to the second. And the reason I did that is because I know that 3 to the third is 27, and that's what I was trying to get to. So if I use my power to power rule, when I have power to power, I multiply. And so I really need 2x to equal just a 3. 2 times x, power to power. I need 2x to equal 3. Divide both sides by 2, and x equals 1.5. And to get it to flip, it'd be a negative 1.5. So again, 3 to the second is the same as 9. And so I wanted to look at this and say, okay, I need this to be a power of 3. So how do I make 2x equal 3? I divide by 2, and I get x is 1.5. But I don't just get 27. 3 to the third is 27, but I need it to be a negative, so I put it on the bottom. All right, so that's where we got the answer of negative 1.5. All right, so something a little different here. Again, it might be a little bit above what you've done because it's combining knowledge. And in my Algebra 2, we haven't learned about rational exponents or fractional exponents being the same as roots. So we have log base 5 of the square root of 5. And we're going to set it equal to x. So I have 5 to some power equals the square root of 5. And that's what's different. We know the square root of 5 is an irrational number. And we know, by using our calculator to get an estimate, that it's about 2.24. That is what the square root is. So 5 to the first is 5. And 5 to the 0 is 1. So I know that my power has to be between 0 and 1. And so I am going to basically tell you that the power is 1/2 or 0.5. And so the reason for that is the square root of 5 is the same as 5 to the power of 1/2. And that comes from a rule, and that rule is the nth root of a to the m is the same as a to the m over n. So any root of a number becomes a fractional power, okay? And so the power was 1, so that stayed as a 1, and the root was square, and so that becomes my denominator. Again, that might be a little bit more than what you've done. This is something we come into later in the year. Okay, we have log base 9 of 3 equals x, and so by going over that rule, this might help you. This would be 9 to some power equals 3. So again, 9 to the first is 9. 9 to the 0 is 1. So I know my power is between 0 and 1. And I also know that the square root of 9 is the same as 3. And that's why it's a power of 1/2, because a power of 1/2 is equivalent to a square root. A power of 1/2 is what cancels out a power of 2. All right, we have 2 to some power is 16. And so again, we can mess with this. 2 squared is 4, 2 to the third is 8, and the winner is 4. All right, now we have a log base 1/2 of 16. So we'll set that equal to x. And we have a base of 1/2 to the power of x equals 16. Now, what I see is 2 to the 4th is 16. We just did that. 2 to the 4th is 16. But my 2 is in the denominator. So it must be that I have a negative power of 4. And that would be because 1/2 to the power of negative 4 becomes 2 to the power of positive 4. That 2 moves up. And there is my 16. Okay, this changes a little bit now. And we are doing, looking for a different piece here. And so the different piece we're looking for is we're finding what we're taking the log of. So I have 6 squared equals x. And well, that was very simple. X is 36, and I'm done. This is one of those problems where a lot of people just look and say, well, it's different. We didn't solve for that. Well, there's nothing to solve for. Take it out of logarithmic form, because remember, none of these logs were helping me. None of these logs were base 10 that were helping me, so I actually want to put it in exponential form. And the same idea here. I have a base of 5. 5 to the power of 3 is x. 5 to the power of 3 is x. So simply changing it to exponential form, my answer falls out. It's 125. And you want to double check yourself. I mean, we don't want to write 5 to the third is 15. We want to double check and make sure we're doing 5 to the third properly. All right, here we are again. 16 to the power of negative 1 is equal to x. Well, power of negative 1 flips it, so 1 over 16. All right, 9 to the power of 2 is x. And so 9 to the power of 2 is x. There it is. X is 81. A few more down here. We have a base of 1/4, and I think it's good to put this in parentheses to show that the 1/4 is to the negative 2 is equal to x. So I'm going to flip it, and it's 4 to the power of 2, which is 16. Now this one's a little bit different. We've got a base of x to the power of 3 is 64. So if I know this, my answer is 4. 4 to the third is 64, and I'm done. But if I wasn't sure, the inverse of a power of 3 is your cube root. So we could simply come in and take the cube root. Now you might not be using the same calculator as mine, but a lot of the calculators make you define your root. So to put this in, I'm typing in the 3, and then I'm hitting my second function, and there's my power key, and there's my x root key. Oh, and you can't see that. So there's my any power key, and right above it is the x root key. So in the calculator, it should look like 3 and then the x root. So the x is defined as 3 of 64, and my outcome is 4. So x is 4. One last one in the section, we have x, my base, to the power of -1 is 8. So the 1 is going to have an 8 in the answer, and because it's a -1, it's going to flip it. So x is going to be 1/8. And just to put it back for you, it's 1/8 to the power of -1, and there's your 8. All right, let's keep moving here. A lot to go. We have our expressions, and right now we have this written as a single log, and we want to expand it. This teacher said the word log will be used repeatedly, so I guess that was their hint. If you see the word expand, that means you want to write it as separate logs. And so there was 2 rules that we had here, and they're very much related to our power properties. So if I have log base b of m times n, if I have multiplication, I can write them as individual logs, log base b of m plus log base b of n. So basically, if I have multiplication, it leads to adding the logs. We also go backwards. If I'm adding 2 logs, it reverses, and I can write it as a single log using multiplication. Okay, we also have that same idea, but with division, which, much like the power property, when I'm dividing bases, I subtract the powers. So I have log base b of m over n, and that is equal to the individual logs of log base b of m minus log base b of n. And then the order does matter. The numerator should be then minus what was in the denominator. In order to have these logs and write it as a single log using division, they have to have the same base, just like terms have to be the same. All right, so if we look at this, we see that we have the log base 6 of 3 times x. And so if I'm expanding it, I'm going to rewrite this as log base 6 of 3 plus log base 6 of x. Next problem, I see division. So it's going to be log base 2 of x minus log base 2 of 5. And we continue. There's a difference here. There is a power, and that's not going to be a big difference, but it is going to use a property that I want to review. So we have multiplication. So this would be log base 10 of x plus log base 10 of y squared. Now I want to remind you, that base 10 doesn't have to be there. Okay, it's a common log. But to truly expand this, yes, you have broken the multiplication up and written it as 2 logs with addition. But to truly expand it, this power should be brought out front. That's a power property. If I have log base b of a to the p, that is equal to p times log base b of a. So that power comes out as a product. So we would rewrite this log base 10, or just log x, plus 2 times log base 10 of y. All right, next one we have some multiplication, and all divided by 3 here. So I split this up. It's going to be the log of 4xy minus the log of 3. But I'm going to break this up to be the log of base 4 of x plus log base 4 of y. I'm going to throw that in parentheses. We take that sum, and then we subtract log base 4 of 3. In order of operations, we would do the addition from left to right and then subtraction, but I put the parentheses there just to make sure we see it. Okay, this one also has that power, much like the one up here. So I'm going to go ahead and expand it, and it's going to be log base 3 of x squared plus log base 3 of y plus log base 3 of z. And now that I have that, I'm going to use my power product, my power property, and make this written as an expanded product. So I would write it as 2 times log base 3 of x plus log base 3 of y plus log base 3 of z. And what I want to point out about this problem on number 30 and the problem on number 28, that power was only on the y, so it only came in front of this log. It didn't come out front with parentheses. And this power was only on the x, so it's only part of this. I would not put all of this in parentheses unless everything was to the power of 2. All right, one last one. We have log base 5 of 2 plus log base 5 of x. All right, now we're going to take our properties and reverse it. This is where I got into trouble in my last recording and it never saved. They're telling us to condense them using properties of logs, and the word log will only be used once. So my terminology that we used was write it as a single log. So that might be something you see, to write each as a single log, and sometimes you'll be asked to simplify it if possible. These we're just going to write as a single log. First I have to check to make sure they have the same base, and then we're really just taking the property that we had up here. When I have addition, it turns to multiplication, and when I have subtraction, it turns to division. Okay, so I have subtraction, so it's going to be log base 3 of 7 divided by x, and it's as simple as that. If you wanted to write it with 7 and your division sign, you could. Now, one of the issues we have is I have a 2 out front, and notice that 2 does not affect this log. If it was in parentheses, then both of these would be to the power of 2, but it's not. So one of the things we have to do is we actually have to put our power back in its position. So we're reversing this property. We have it out front, and we're going to put it back up. And so anytime I have a log to a power, the power can come out front as a product, but anytime I have a product with a number, it comes back as a power. So I'm going to rewrite this as log base 5 of x to the second plus log base 5 of 3. And by doing that, I can come in and now write it as a single log base 5, and it'd be x squared times 3, or 3x squared. I don't think on this worksheet they do it, but I like to put these in parentheses to show that the whole piece is there. Okay, I have 3 pieces here, and they're all being added. There are no power, there are no products out front, so this is going to be simply log base 4. They are all base 4 of 5 times x times y. 5xy. Here we have that power, so we need to bring that up, because we can't have that 3 out front. When you write it as a single log, that 3 is not supposed to affect this, so it cannot stay out front. So I have to rewrite this as log base 10, or just log of x to the third, minus log base 10 of 4. And so as a single log, it'd be log base 10 of x to the third over 4. And again, the order is important. This is being subtracted. The log base 10 of 4 is being subtracted, so that is in the denominator. All right, same idea. You don't have to rewrite these, but for the purpose of making sure you know where my numbers come from, I am. So I'd be writing this and putting the power back, and taking that power and putting it back. And so that would be log base 2 of x to the second minus log base 2 of y to the third. So I keep my log base 2, and I'm subtracting, so it's going to be x squared over y to the third. Now at this point, there's nothing I can do, but if these were both x's, I would definitely reduce and clean up. All right, in this problem, we have addition and we have subtraction. So these are going to be in our numerator, denominator. I'm not going to rewrite this. I'm going to show that it would be x squared. So I'm going to have log base 3 of 4 x squared. So there's my 4 times my x squared, all divided by 5. Couple more here. So I have my log base 2 of x minus 2 times this, so that has to go back up into its position. And we have a problem that these are not the same base, but I'm going to act like this is a typo. So if these weren't the same base, I would be stuck, and I cannot write this as a single log. but I have a feeling that that is just a typo. So I'm going to go ahead and change that out to make it a 2 down there. Doesn't really look like it's small. So we would have log base 2 of x over y squared. All right. Bring our power back up in its position. Same thing here. So start with addition here. And we have 2 to the third, and that's just going to give me a 9. Or sorry, 2 to the third, that's going to give me an 8. So this would be log base a, they're all base a, of 8 times 6. So I'll go ahead and write this, of 2 to the third times 6 over, this would be 4 to the second. So this is an example, like I just talked about, that we would want to clean up. So this would be log base a, and I'm going to go ahead and just put this together. So our 2 to the third gives us 8, and then we're going to take that times our 6, and we get 48 on top, and we get 16 on the bottom. And then we always want to reduce our fraction, and this divides nicely. So we really have a simplified answer of log base a of 3. So you always want to clean that up. Okay, now one of the things we're doing here, it says condense the left side of the equation and then solve for x. So some of you might be looking at number 40 saying, well, wait, there's nothing to condense. And there is, because there's no addition or subtraction, but you have that power. And so again, I want to set these equal. So this is one of the next lessons that if you haven't covered, you'd be covering. And it's basically, if you have the log base b of x is equal to log base b of y. If this is true, then x must equal y. If I have log base b of this number, and it's equal to log base b, same base, of y, then the x has to equal the y. So this is a logarithmic rule. And so basically, if I'm taking the log of both sides and the bases are the same, then what I'm taking the logs of must be equal. But I can't have that 2 out front, and I can't really divide by 2 because I'm stuck with it. So I'm going to pop that 2 back up there. So I'm condensing it. Log base 4 of 3 squared equals log base 4 of x. So see how my log bases are the same? Then 3 squared must equal x. And so 3 squared must equal x, and that means x equals 9. So again, I'm not really using my log base 4. I'm using that these are equivalent logs, and so what I'm taking the log of must be equal. All right, so I cannot set logs, plural, equal to log. So what I want to do is I want to condense this, or I want to write it as a single log. And so this would be log base 10, or just log, of 3x, x times 3, is equal to log base 10 of 12. Okay, so they're both log base 10, so then that means that the 3x must equal the 12. And so if 3x equals 12, I can solve that by dividing by 3, and x is 4. All right, so here we go. We have this, and I, again, want to set these logs equal. They're all log 3. There's an equal sign here. That is the big difference between what we did up here and what we're doing down here. And so I need to write this as a single log. And so this would be log base 3 of 5x equals log base 3 of 2. Okay, so they're both log base 3, so the 5x must equal 2. All right, now we want to make sure we actually divide by the right number, and so we get x equals 2/5, or 0.4. So again, 43 is like the first one we started with, and we have that 2 that really needs to come up here. So I have log base 3 of 2 squared equals log base 3 of x. And so 2 squared must be equal to x, and so x is 4. Same idea, take that, bring it up, and so I have log base 10 of x to the third is equal to log base 10 of 27. They're both log base 10, so x to the third must equal 27, and if you know 3 to the third is 27, that's great, you're done. If not, again, you could come in and take the cube root, not the square root, but the cube root. All right, final problem for now. we have same idea, pop that back into its power position. So you could jump this step, but again, for teaching purposes, I'm writing out the steps. All right. So they're all base 5. This is addition, so it is a product, and that would be log base 5, and 2 to the third is 8. So log base 5 of 8x equals log base 5 of 24, and so 8x must equal 24, and that means that x is 3. All right, so that was a review of a lot of your logarithmic properties. Again, we didn't go over every property, and make sure you keep practicing.